So till now, we have studied the regression modeling, which is the one side of supervised learning or machine learning. Regression is where when your dependent variable is numerical and continuous. And in regression model, we have studied the primary algorithm, multiple linear regression. Now, within the supervised learning, the other set of algorithms are classification algorithms when dependent variable, numerical, multinomial. So the other side of the machine learning and supervised learning is the classification algorithms. Within the classification algorithms, the primary algorithm is binary logistic regression explains the relationship a binary dependent variable y and multiple independent variables. Binary logistic regression explains the linear relationship between a binary dependent variable y and multiple independent variables x's. Binary logistic regression is an equation. Binary logistic regression is an equation. Like how we get equation in multiple linear regression, binary logistic regression is also an equation. So in multiple linear regression, we solve for the coefficients and the intercept, and we create the equation, and we use that equation for prediction purposes. Similarly, in binary logistic regression also, you have to solve for the coefficients and intercept, and you will create a equation for predictive purposes. That is the concept of the logistic regression. The equation is P is equal to exponential to the power of intercept beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus n xn. The denominator is the same equation, or the short form of the equation is P is equal to 1 divided by 1 plus exponential to the power of minus z. Z is the linear regression equation. So logistic regression is also an equation which looks like this. Here, P represents that lies between 0 and 1. So in logistic regression, we get predicted probability. In classification, predicted probability is the outcome. In regression, we get predicted value. In regression, we get a predicted value. Here you will get predicted probability. EXP is exponential, which is 2.7138 something. B0 is intercept. B1, B2, B3 till Bn. We call them as coefficient. X1, X2, X3 till Xn. We call them as independent variables. So this is the equation of binary logistic regression. So we get predicted probability. The classification rule for all classification algorithms, probability greater than equal to 0.50 will be classified as 1. Probability 0.50 will be classified as. So based on probability, we will generate the classes. 1 will be, 0 will be, no, alphabetical order. So binary variable will be in the form of 0 and 1. So once we build a model, we get the predicted probability. Based on the predicted probability, we will create the predicted class using this classification rule. So binary logistic regression is the primary classification algorithm we use. They are completely two different algorithms. That is a regression model. This is a logic classification model. This is supervised learning. Dependent variable is non-numeric. Read the statement clearly. It is clearly written there. Dependent variable is non-numeric. Yes or no? Regression will be done when your dependent variable is numeric and continuous. They are completely two different class of algorithms. So regression is when your dependent variable is numeric and continuous. Classification is when your dependent variable is non-numeric. So I have written it very clear. Binary means yes or no. So you have to look at the way, what you call, the model is completely different. The class is different. The process is different. The outcomes are different. I have given it here. Multinomial means what? more than two classes. P probability is equal to exponential to the power of intercept plus beta 1 x1, beta 2 x2 till beta n xn divided by 1 plus e to the power of intercept plus b1 x1, b2 x2 till bn xn. The short form is 1 by 1 plus e to the power of z, intercept plus b1 x1 plus 2 bn xn. So P is the probability, E is the exponential, intercept, coefficients, independent variables, classification rule is if the probability is greater than equal to 0.50 will be classified as 1, probability less than 0.50 will be classified as 0. The assumptions. There must be a logical, linear, the dependent variable and independent, no multicollinearity, 50 observations per variable. Sample size required is minimum 50 observations per. These are the basic assumptions which we have for binary logistic regression. The interpretation, the primary metric calculated confusion matrix. The primary metric is accuracy, which is calculated from the confusion matrix. Confusion matrix is a cross tabulation. So confusion matrix is a 2 by 2 cross tabulation of actual class and predicted class. So the confusion matrix is at the core of all classification problems. For all classification problems, we have to do a confusion matrix, which is a 2 by 2 cross tabulation of actual class and predicted class. So actual positive class and predicted also is positive class. We call that segment as true positive. Actual positive and predicted, actually the data says it's a positive class, but the model has predicted as negative. We call it as false. Class is negative and predicted class is positive. We call it as false. The actual class is negative and predicted class is also negative, true, negative. So in confusion matrix, you have 4 quadrants. One quadrant, the first one, where you can see the actual class is positive. The predicted class is also positive. We call it as true positive. Actual class is positive, predicted is negative, which is false negative, which is a wrong prediction. Basically, it's a wrong, and our data actually says it is a positive class, but your model predicted it as negative, which is called false negative. So because it's a wrong prediction. Similarly, actually your data says it's negative, but the model predicted it as positive. Again, it is a wrong prediction. We call it as false positive. So the confusion matrix will look like this. So this is the confusion matrix. Why we use positive and negative notation is based on your business problem, the yes and no will become positive and negative. The concept of yes and no will become positive and negative based on your, in case of loan default, loan default, yes or no. Loan default no is positive or negative. Loan default no, there's a variable called loan default, yes or no. Yes or no means if the customer has defaulted on loan, it is yes. If the customer has not defaulted on loan, no. Default no is positive. That means the customer has paid the loan, EMI, he didn't default on the loan. Here no is positive. Similarly, customer has made a purchase. Made a purchase is yes is positive, no is. So the yes and no means different, have different has different interpretations in different business problems. So we can't say yes is always positive, no is always negative, or vice versa. So to avoid the problem, we have come up the confusion matrix is based on the positive and negative class. And what is positive and negative class depends on your business problem. It depends purely on your business problem. So according to your business problem, you have to identify your positive class and the negative class. And this confusion matrix have to be interpreted accordingly. Actual class is positive, predicted class is also positive. It is called true positive. These are all correct predictions. Actual class positive, predicted class is negative. This is wrong classification. We also call this as type 2 error. Actual class is negative, predicted class is positive. We call it as false positive. This is again wrong classification. Actually negative, predicted is also negative. We call it as true negative, which is correct classification. These two errors are very important. The two errors are very important. These two are wrong classifications. These two are correct classification. Now, which error is most dangerous? Type 2 error has COVID. Patient has COVID, RT-PCR test, but RT-PCR test gave negative result. RT-PCR said no COVID, which is dangerous or not? Which is dangerous. The patient will not take any medications. Here, there are more chances of him to be die. He will die if he. In type 1 error, RT-PCR test gave positive result. So what will the patient do? He will take some medicines. He will take some medicines for which he will have side effects. For that, he will not die. He will have some side effects and unnecessary medication he will take. But in case of type 2 error, where he has COVID, the test gave negative result. And if it gets worsened, he will die of the disease, which happened in the real-time scenario. The RT-PCR test was giving lot of false negatives in the initial days of in 2019. That is the reason why there were many fatalities in the. Even today, RT-PCR generates more than 50% false negatives. Even today, RT-PCR generates false negatives. It is not foolproof. Generally, a test will be certified by the governments only if it has false negatives less than 10%. But because of COVID and because of urgency, we are using a test which is not at all accurate. Even today, RT-PCR generates lots of false negatives, which is causing problem for the people. So we can't directly go with RT-PCR test. That's what people are saying. We can't blindly go with RT-PCR test, put the patient in 72 hours observation. That is what governments realized initially, and they did. 72 hours observations, even if you see symptoms and the test negative, you start medications and keep it under control. It took them almost 3 to 4 months to realize that RT-PCR was completely giving them false negatives. Because of which the fatality rate was very high in US. Because in India, doctors can give medications even though test is negative, but in US they can't. Because the insurance companies will not agree to it. That's why US has a lot of fatalities. Because the test was negative, doctors could not start the patients on the medications for which the insurance companies will never give them bill. So they left them like that and the people died in US and UK. Later, insurance companies, the governments realized the problem and then they said, even if it is negative or false positive, you have to give medications and they have to take medications, whatever may be the test result. Even today, 7 days is the observation period for a COVID patient, even though the test may be positive or negative. So this is the problem with false negative. They are very compared to false positive. And in our real-time data science also, false negatives are very dangerous. Approving loan to a person who has already defaulted on, that is risk to the bank, right? So you have to be very careful when you are dealing with confusion matrix and false negative. So when you see a lot of false negatives, your model is not good. The model should have as many as possible lesser false negatives. That is the important thing. If you look at the false negatives, the most important metric is sensitivity. Apart from accuracy, the primary metric is accuracy. Along with accuracy, we must look at other metrics also. We must also look at other metrics. One such metric is sensitivity. You can see here, true positive divided by true positive plus. After accuracy, we also have to look at specificity. True negative by true negative plus false positive. Opposite of sensitivity is also called as recall. Sensitivity is also called as. So once you look at your confusion matrix, you need to plot other metrics also. Sensitivity or recall, specificity, precision, true positive by true positive plus false positive, overall positive prediction rate. And then the accuracy formula, true positive plus true negative divided by true positive plus true negative plus false positive plus. This is the formula for accuracy. All classification models by default will build a confusion matrix in the backend and dot score function. In regression, dot score will give us R square. Whereas in case of classification, dot score will give us, as part of the algorithm process in Python, all classification algorithms will also predict, create a confusion matrix in the backend, calculate the accuracy from that confusion matrix, and the dot score function will generate the accuracy, which is calculated from the confusion matrix. So this is a confusion matrix, which is a 2 by 2 matrix. 2 by 2 means 2 rows and 2 columns, right? It's a cross tabulation between actual class and the predicted class. And the positive negative depends on the business problem. These are the various formulas. The primary is accuracy, true positive plus true negative, divided by true positive plus true negative plus false positive plus false negative, sensitivity or recall. And one more important is the F1 score. These days, one of the most important metric is F1 score. So 2 into precision into recall divided by precision plus recall. 2 into precision into recall divided by precision plus recall. So F1 score, 2 into precision into recall divided by precision plus recall, or 2 into true positive divided by 2 into true positive plus false negative. Recall is nothing but sensitivity. Recall is nothing but sensitivity. Now, even more metrics are there. If you look at them, there are many metrics, but in business, we go with some of the base. These are the basic metrics which we use in business. But if you look at your confusion matrix, these many can be done. Here the reverse, this is the actual class, this is the predicted class. This is the actual class, this is the predicted class. So false negative came this side, false positive came. So sensitivity, recall, precision, false omission rate, false discovery rate, negative predictive rate, positive likelihood ratio, negative likelihood ratio, diagnostic odd ratios. So there are many metrics which you can calculate from confusion matrix, but in business, we only use the ones which we are discussing in this confusion matrix. So this is the Python based output. When I discuss the statistical output in R, we will discuss the statistical output also. In statistical output, you get AIC, null deviance, residual deviance, independent variables, p-values, all those things will be there. So the statistical interpretation of the output will be different in statistical softwares. So statistical softwares will generate a statistical output where you have AIC, null deviance, residual deviance, and independent variables p-values. Whereas we don't get them in Python. In Python output, so model.score will give you, and you will get intercept for creating the equation. And we can print other metrics also using classification report. All right, got this? So the bank data set. So all of you open that notebook and run all cells, or if you didn't, you can import it. So 45,211 observations, no missing values, object and int are there. So all of you have imported the data. Now you can see here, we have two types of variables. Object calls is equal to bank data dot select underscore d types include is equal to square bracket single quote. Numeric calls is equal to bank data dot select underscore d types include is equal to np dot number. Object calls dot shape. Numeric calls dot. So 10 object calls and 7 numeric calls. Check in numeric calls. Do we have any category calls? Check with the numeric calls. Do we have any category calls? So any category calls? Check the description which I sent you. I sent you the data description also, right? Day is last contact day of the month. Duration is last contact duration in seconds. Campaign, number of contacts performed during this campaign. Previous number of it's a numeric variable. P outcome is a categorical variable. P days is numeric. So day is also numeric. I think there is no categorical. Numeric, no? It's given clearly. Read the data description. Number of contacts performed during this campaign. It's a numeric data, includes last contact. I have sent this file along with the data file also. You can look at the text file. So numeric data does not have any categorical variables. Object calls underscore encode. Sorry, we have not imported the function. So from sklearn dot preprocessing label encoder. LE is equal to label encoder. Object calls underscore encode is equal to object calls dot apply LE dot fit underscore transform. You have to separate them and then do the label encoding on them also. Bank data underscore df pd dot concat numeric calls comma object calls underscore encode comma access is equal to 1. So numeric call scaling is not a problem in logistic regression. Scaling is a problem. You have to do it in regression, but in logistic regression, it will not create any problem. Data is compulsory in regression. It is not compulsory in classification because we are getting a probability, not a value. Predicted probability. which lies in a range 0 to 1. It cannot go beyond 1, it cannot go beyond 0. When you are predicting a value, it can be anything. Whereas in probability, the range is fixed, which is between 0 and 1. Classification models. When you are doing classification models, scaling of numerical data is not compulsory or not required. Classification models, scaling is not compulsory or required. Y is equal to bank data underscore df dot y. X is equal to bank data underscore df dot drop, comma, axis is equal to 1. Split the data into y and x. Yeah, good morning. All right, all of you are here. From sklearn dot linear underscore model, import logistic regression. Logit is equal to logistic regression. Logit model is equal to logit dot fit x comma y. So iterations issue. Logit model dot x comma y. So this is accuracy. Accuracy from confusion matrix. This is accuracy from confusion matrix. 88.95. It said iterations are not enough for calculating the, it reads iterations. So it gave an error saying that iterations are not enough, or you scale the data. Scaling the data now is a problem because that's a complicated process. So I have just increased the iteration. Even if we scale the data also, we'll get the iterations problem. Once you manually calculate, you will understand what iterations are needed. If you are familiar with linear programming, there are three things in linear programming in mathematics: minimization of error, maximization of profit. When you are reducing the error, you will use multiple iterations to reduce the error by changing weights. In linear programming, by changing weights, we try to reduce the error. Now that process is an iterative process. It requires iterations. Hundreds, thousands of iterations are required for reducing the error to a lower level. In Excel, we have something called solver. Solver uses that iterations to reduce the error, and once it can't reduce error further, it will stop. So we have to increase iterations. Logit predict is equal to logit model dot predict pd dot crosstab y comma logit. So we got the confusion matrix. So these are correct predictions. 39,085 plus 1131. These are the correct predictions divided by 39,085 plus 837 plus 4158 plus 11. You get the same value which you got in score. So in this matrix, if you look at the thing, our business problem is whether the customer has booked a term deposit or not. If you look at our data description, has the client subscribed to a term deposit? Yes or no? Term deposit means fixed deposit. No is positive or negative. Term deposit, no. That means the customer did not subscribe for the term deposit, which is, so 0 is negative, 1 is term deposit subscription, no is 0, and yes is, so what is this 39,085? 39,085 is true, negative. What is this 837? False, positive. 4158 is, and then 1131 is true. So the model is predicting false negatives. Outliers are there, you will perform feature scaling. Outliers are there, you will perform feature scaling. So you want to display in a colorful format, this is the function. We have positive, negative here. Dot from underscore predictions. From underscore predictions. From sklearn dot metrics classification report. Classification report y comma. What is error you are getting? From underscore prediction. You have not added the path, right? Which one you have to see the interpretation of precision. Correctly predicted positive observations to the total predicted positive observations. Precision means correctly predicted positive observations to the overall predicted positive observations. Take for example, all the passengers that labeled as survived. How many actually survived? Titanic data set, right? So labeled survive, and how many survival your model is predicting. High precision relates to low false positive rate. That means high precision means it's a good thing. If your precision metric is high, it is good. Now overall precision is good. You can see here weighted average and macro average of the precision is good. But if you look at the precision of the minority class, it is bad. This we call it as imbalanced data. Later we will discuss. In class, like in regression, we have problem with skewness, outliers, and kurtosis, right? In classification, we have problem of imbalance. Like we have regression problem of skewness, outliers, kurtosis, which creates a lot of problems. Similarly, in classification, we have a problem called imbalanced data. Imbalanced data means our dependent variable has 39,999 zeros, only 5,289. Very few ones are there in our dependent variable. Many zeros are, which is affecting the prediction of the minority class. See the predictions of the minority class, they are very, very bad. Look at the precision predictions of the majority class, they are very, very good. We have a problem called imbalanced data problem in classification. Like we have problem of skewness, outliers, and kurtosis in regression. In classification, we have imbalance. Imbalance means very large difference between the classes or levels in your dependent variable, which will affect the predictions. It is affecting, right? It is false negatives are very high. Why false negatives are very high? Because of the imbalance. Because of the imbalance problem, we have false negative. If we balance this data, we have algorithms to balance, undersampling, oversampling. We can use those algorithms. If we balance this data and rebuild the model, these metrics will be corrected. False negatives will be. We'll have a separate session later once we have done the classification algorithms. We will discuss the, right? This is the interpretation of precision. Overall positively predicted ratio. Overall positively predicted. Similarly, the other metric is recall. Recall, also called as sensitivity, is the ratio of correctly predicted positive observations to all observations in actual class S. The question recall answers is, of all the passengers truly survived, how many did we label? That means how many our model has predicted. We got recall of, here we got how much recall? We got a recall of 0.89. Good for this model as it is above 0.50. But if you look at the macro level recall, it is less, 0.60. Weighted recall is 0.89. So recall and sensitivity are same. So if you are looking at these formulas, precision, recall. Now, the important metric is accuracy. What is accuracy? Correctly predicted observations to the total. See, accuracy is a good metric as long as your false negatives and false negatives and false positives are closer to one another. As long as the false negatives and false positives are closer to one another, your accuracy is the best metric. But if your accuracy, if your false negatives and false positives are there is a difference between them, like in our case, there's a huge difference between false negatives and false positives. 837 false positive, 4,137, 158 false negative. There's a huge difference. In this case, we can't simply go with accuracy. We can't simply go with accuracy. Along with accuracy, we also need to check precision, recall, and F1 score. Precision, recall, and F1 score will become important along with accuracy when there is a big difference between false negatives and false positives, or when the data is imbalanced. When the data is imbalanced, we cannot simply go with accuracy. We also have to refer other metrics like recall, precision, and F1 score. The model that has all these metrics greater than 0.70, 0.70 to 0.95. Oh, I forgot to give the accuracy metric. The accuracy must be 0.70 to 0.95. Less than 0.70, underfitting, greater than 0.95, overfitting. We want all the metrics to be between 0.70 to 0.95. Then we can say our model is a best fit. Our model will become a best fit model when the accuracy and all other metrics are in the range of 0.70 to 95. Now, the next thing you need to understand is the precision, F1 score. Now, like I told you, in case of imbalanced data, the preferred metric is F1 score. In our case, F1 score is around 0.87. Weighted F1 score is 0.87. See, when you have imbalanced data, along with accuracy, we also need to look at F1 score. The F1 score, when you are looking at imbalanced data, Along with accuracy, we must also have a look at F1 score in case of imbalanced weighted average of precision and recall. F1 score is the weighted average of precision and recall. So uneven class distribution, also called as imbalanced data. Uneven class distribution or imbalanced data, F1 score is more reliable than, but accuracy is the primary metric. First metric we always look at is accuracy. So in case of imbalanced data, it is better to look at both of them. So these are the metrics which you need to understand: precision, recall, and F1 score. This is one of the common interview questions regarding F1 score, precision, recall, and accuracy. You will definitely get. So this is the process of logistic regression. One more important metric which you need to understand is area under the ROC curve. So AUC curve or area under the ROC curve. This is also very important metric. So probability that the model ranks a random positive example more highly than a random negative. Area under the curve, aggregate of performance across all possible classification thresholds. One way of interpreting the AUC is the probability that the model ranks a random positive example more highly than a random negative example. From sklearn dot metrics plot underscore ROC underscore curve, plot underscore ROC underscore curve, logit comma x comma y. So we have an AUC of 0.86. We have an area under the curve of 0.86. Area under the curve, the probability of positive being more classified than, we'll change something, 1 second. This is deprecating. So ROC curve display, ROC curve display dot from underscore estimator 0.86. Use this methodology because the plot ROC is being deprecated. Completely uninstall and install the latest version, Python 3.9 Anaconda. Yeah, it will change because there is something called random state. Random selection will be there. Iterations will change.
Okay.
Random state. You have to fix the random state. There is an option called random state, and you have to fix it by a number. Random state 1, 2, 3 or something. So we have a process of what you call fixing the random state. 1, 2, 3. If you fix it, then it will not change. Random underscore state is equal to 1, 2, 3. Then your output will not change no matter how many times you run the model. You have to give it here, where you define the logic function, and then y, our dependent variable, copied here. So we have to convert this into dummy. Y underscore dummy is equal to if is equal to no, comma 0, comma 1. If the cell value is no, comma 0, comma 1. So I will double click. Yeah, S is 1. Okay. So we have converted the variable, which is our dummy variable, into zeros and ones because it's in text, right? Text is not taken. So we have converted it into 0 and 1. Now, the first process is what we will do is we will create intercept and the variables and the coefficients, and we will assume some dummy coefficients like 0.05. We will assume some dummy coefficients like this 0.05. Some dummy coefficients you have to assume. Now we will calculate the z. So we will calculate the z, which is equal to intercept. You have to fix it by pressing Fn plus F4 plus coefficient of age Fn plus F4 multiplied by actual value of age, coefficient of balance Fn plus F4 multiplied by actual value of balance plus coefficient of duration Fn F4 multiplied by, the coefficients must be fixed. The intercept and the coefficients have to be fixed by pressing Fn plus F4. The $2 signs have to be there, and you will select the first row of data, actual data points also as multiplications. You have this A2, B2 and C2, which should not be fixed. The values in J column must be fixed by pressing Fn plus F4. So you'll get the value 123.15. I will double click, it will calculate for all the 45,000 rows. So you have to fix the coefficients and intercept, multiply with the, then we will calculate sigmoid of Z is equal to 1 divided by 1 plus EXP, exponential open bracket minus sigmoid of Z, 1 divided by 1 plus e to the power of minus Z. You will get the values as ones and some values. Basically, this is your probability. This is your probability. 1 by 1 plus e to the power of minus Z. Let me show you let me just take the formula. So this is the log loss formula, which is equal to y into log of is equal to y into log of probability plus 1 minus into log of 1 minus probability. So we got a number error. We got many number errors. How many number errors we got? Let me just check. There are many number errors. 23,000. Zero. If you are looking at data scientist position. If you are being recruited for a data science position, they will definitely ask you for at least one algorithm to explain. They will ask you to choose. For this data, it is not working yet. Logistic regression is not working for this data. We have to use some other data. Hello? Third floor mein de do, reception mein. Reception mein de do. Here you got probabilities are also not coming. So this data is not suitable for doing a logistic regression. We'll work on some other data in the next class. I think telecom chain would be the best option. We'll work on telecom chain data next class because this is generating numerical errors and the probabilities are not calculated. So we will work on some other data. But this is the process. We initially start with some assumption of weights, coefficients, then we calculate the Z value, then the sigmoid Z, which is nothing but the probability. Then using the log loss function, we will calculate the sum log loss and we use the solver to minimize the loss by adjusting the coefficient. So you will finally get a model with adjusted coefficients and that will be a final model. Now solver is an iterative process. Linear programming, minimization of error. Using different values at different iterations, it will try to reduce the error. It uses derivative calculus, slope of a gradient. And if it doesn't reduce the error, further it will stop. As long as it can reduce the error, the solver will use iterations to run. The moment it is the error, and in the next iteration, if the error starts increasing, it will stop and it will give you the final. So next session, I will tell you how to do it using another data set, where we can actually calculate the whole regression process, which is the same process which is implemented in the softwares. Okay. So this is the fundamental classification algorithm called binary logistic regression. This binary logistic regression is very, very important because most of the business problems in real-time scenario are binary decisions or binary classification. Binary decisions or binary classifications, you have to use binary logistic regression as the baseline model. And from now onwards, we are going to discuss models that work both as classification model as well as regression model. The two models which we have discussed, multiple linear regression can be implemented only as a regression model. It cannot be implemented as a classification. Similarly, binary logistic regression can be implemented only as a classification model. It cannot be used for regression model. But the next set of algorithms onwards, we will be discussing those models which work both as a classification algorithm and also work as a regression algorithm. These advanced algorithms will work on both classification data, will also work on regression data. For regression problems, residual is the most important. Residual, also called as error. What is residual? Actual minus. In classification, everything depends on probabilities. Everything is dependent on probabilities. Probabilities will be calculated. Based on the probabilities, you will be finding the what we call predicted class. From that, we create a confusion map. So the fundamental of regression is residual. The fundamental of classification is predicted probabilities. Now you can see that also here. In our case, logic model dot predict underscore proba. If you use directly predict, it will give you class predictions. It will give you class predictions. So I like this predict of X. So it is giving you zeros and ones. Similarly, if I use logic model dot predict underscore proba of X, we will get the predicted probabilities. Now we got two sets of probabilities. For every observation, we got two sets of probability. This is probability that the observation being classified as 0 the probability, the observation as classified as. Now, which probability is higher? Zero's probability is, once you have this as higher, the final predicted probability is, now for the last observation, you see it is 1, right? Now, bottom you see here, which has the highest probability? One class has higher probability. 0 is 0.423. One probability is 0.576. So the final probability is, similarly look at this observation 1, because the probability is greater for class 1. You can do like this. PD dot data frame comma columns is equal to square bracket 0 comma 1. 0 probability and 1 probabilities. Now see here, this 0 is higher, 1 probability is lower. So final prediction will be 0. Here 0 probability lower, 1 is final predicted will be 1. Same thing here, 0 is lower, 1 is higher. So as the model predicts the probabilities, based on the probabilities, the classification will be done. So in all classification problems, probability is the fundamental. In all regression problems, residual or error is the fundamental. In interviews, they'll ask you, what is the fundamental thing in regression models? Residual or error? Because everything starts from residual, right? From residual only we calculate sum square residual, sum square total. From that only we calculate R square. I showed you in the previous class, right? So from there only everything will. Similarly, in case of regression, everything starts with predicted. Then you predict the class. Then you once you predict the class, you do the confusion matrix. From confusion matrix, you'll calculate accuracy, sensitivity, recall, precision, F1 score, and all other metrics will follow. Even if you are looking at statistical outputs, we have this Wald statistic or log likelihood ratios, odds ratios, all are calculated based on probability. So classification is probability, regression is mean square error or root mean square error. So mean square, if you see mean square error, then it becomes a regression problem. If you see class probabilities, it becomes a classification.
How do we showcase the entire period of set option?
Yes, yes. But again,
it's not counting. When I try this,
see, even set option has limitation, not more than 500 rows. Because the window size you have to alter. PLT dot figure and then fixed size you have to change. You have to increase the window size and all. Instead of doing that, write it into a CSV file. Don't do anything here. Write it into a CSV file. 2_CSV. Then you can see as many rows as you want, right? Okay. మీరు ఇక్కడ రావాలి గచ్చిబౌలి టెలికాం నగర్ బస్ స్టాప్ తెలుసా? అదే ఫ్లైఓవర్ ఎక్కక ముందు లెఫ్ట్ సైడ్ ఉంటుంది. పుష్పక్ బస్ స్టాప్, పుష్పక్ ఎయిర్పోర్ట్ బస్ స్టాప్ ఉంటుంది కదా, లెఫ్ట్ సైడ్ కి ఫ్లైఓవర్ ఎక్కక ముందు, గచ్చిబౌలి ఫ్లైఓవర్ ఎక్కక ముందు లెఫ్ట్ సైడ్ ఉంటుంది. ప్రకాష్ లైట్స్ బిల్డింగ్ పక్క బిల్డింగ్. దీంట్లో పంపించిన లొకేషన్ ఆల్రెడీ ఓకే, నేను పంపిస్తాను. నేను చెప్తానమ్మా, బహుశా వెడ్నెస్డే నాకు డ్రైవర్ అవసరం అవుతుంది, వెహికల్ పంపిస్తాను సర్వీస్. వెంటనే నాకు ట్యూస్డే రేపు ఫోన్ చేస్తారా? వెడ్నెస్డే బుక్ చేయండి, నేను వెడ్నెస్డే పంపిస్తాను. డ్రైవర్ని పంపించండి, వెహికల్ పంపిస్తాను. మార్నింగ్ టైం పంపిస్తే మా పేరెంట్స్ ఉంటారు, నేను లేకపోయినా వాళ్ళు వెహికల్ ఇస్తారు. మీరు ఎక్కడి నుంచి ఫోన్ చేస్తున్నారు? మూసారాం లక్ష్మి ఉంటాయా? ఓకే, నేను ఒకసారి మీకు కాల్ చేస్తానమ్మా. నేనే ఉండాలి, నేను ఒకసారి చేస్తాను. ఓకేనా? నేను చెప్తాను మీకు, నేను చెప్తాను. ఓకే, నేను చెప్తాను ఏ డేట్ అనేది కొద్దిగా నేను చూసి చెప్తాను. ఓకే.
Yesterday's thing, Saturday max power and torque lighting.
What doubt?
Max power and torque.
So what doubt we have?
After we tried changing the data type, put that under numerical columns and we started.
Torque is what? Torque is a numeric variable, na? Torque is a numeric variable, right? But they are coming in object columns. Dot as type, it didn't convert. So you have used IDX max for filling the torque value counts. It's not greater than, here it is less than, na? E minus 129. How it is greater than? It is reject null. I've been telling you P value, you have to look at complete value. This is interpretation wrong. E minus 129. Here also you made a mistake. You are not looking at the complete P value. All interpretations of hypothesis are wrong. All the hypotheses you have to correct. Here you should not, you have to calculate age. Could not convert, you did not do label encoding. Where is the label encoding? Label encoding or get dummies have to be done, na? She got one, RMSE of 0.64. But that's a very, you have scaled logarithmic transformation you have done, na? So you have done logarithmic transformation, so you got 0.64. as the RMSE. You have calculated age? Yeah, car age you have calculated. Fuel cellular type transmission you have done correctly. Get the miss. Regression score is 0.590. Just use get the miss, na? You have used, you might have used label encoded. RMSE is 0.64, huh? No, I think it will be larger RMSE.